This is my classroom demonstration video for page 905, talking about rotations now. So I'm just going to, just like last video, I'm just going to jump into it. First thing that you need to do is it gives us a lot of important information when you know about rotations. So there's some key concepts and ideas that we need to talk about before we actually get into the questions. And that's kind of what it goes through here, is to actually see how much a shape or points have rotated, you can actually draw specific rays from one point to another. So as they have here, from the origin they drew a ray through one of the points, and on the other side they drew a ray through the same point after it was rotated, and that made a 90-degree angle, which tells us this original shape was rotated 90 degrees. Another important thing is that if you have a positive angle of rotation, your shape is translating counterclockwise. If you have a negative angle of rotation, your shape is rotating clockwise. So that's also important to know. And there'll be some more key ideas here at the bottom, but that's basically what we want to talk about at the beginning. And then they already applied it for us, as you can see, and you'll see why. This is the most important thing here, is your rules. So for a 90-degree rotation, your x-coordinate and y-coordinate, they flip, and your y becomes negative and your x stays the same. For a 180-degree rotation, your x and y, they stay in the same place, so the coordinates stay the same, but they both become negative values. Okay, the 270-degree rotation, the x and y are flipped, and instead of the y becoming negative, the x is negative. Now, you're probably wondering why there isn't a 360-degree rotation on here, but think, what would a rotation of 360 degrees be? Well, I know a circle is 360 degrees, so that would just end up at the same place I started. So that's why they don't have it on here. It's because it would be the same exact coordinates as you started. And as you can see, 180 degrees, your coordinates, because it is rotated across a 180-degree line, which is a horizontal line or a vertical line, these coordinates just are the opposite. They flip. Okay, so now we're going to go to one of the examples, and we're just going to plug in using the rule of our coordinates. So first try, it says the coordinate of the vertices of quadrilateral HK are, and as you can see, they provide us with coordinates here. So I have H is 1, 4. Okay. So let's do H is 1, 4. J is -1, -4. And K is -3, -2. So I've got my x coordinates and my y coordinates. Now it says this shape is rotated 270 degrees. Now we could scroll back to our rule and look at it, but I've actually got it right here. So at 270 degrees, it's a positive rotation, so I know it's rotating to the left. And the rule for that is your x and y's. So the rule for 270-degree rotation is that x coordinates and y coordinates change. The y comes first, and at the end, the x changes to a negative. So as you can see, that's kind of flipped here, and we're going to go through, and I'm going to mark the new coordinates. So h, I know this is my x, this is my y. Right? If I rotate that 270 degrees by using this rule, my y coordinate will come first now. So my 4 comes first. And my 1 and my x actually changes to a negative. So now that's 1. That would be -1. And that would be for h on top. That tells me that that's after the rotation was completed. Okay, for j, I rotate that 270 degrees to the left using my rule. The x coordinate, or the y coordinate, will come first now. So that stays -4. and the x-coordinate will change to a negative. Well, this x-coordinate is a -1. So if I change that, I have to change it to another negative value. There's only positives and negatives. So if I have a negative value that I have to change to a negative, it's actually going to change back to a positive. So this -1 will now become just a regular one. And that is for J. And lastly, we have K. So -3, -2. So again, the -2 and the Y value will come first. And my -3 will change to a regular 3 because I needed the opposite, and it will go last. And that is for K. Okay, those are my new vertices. The resulting image quadrilateral HJK. Using the rule, let's scroll down to our last one. Here they describe in their rotation. Also, you can use the coordinates to figure out what kind of rotation you have, or again, you can draw the rays. So here, they drew an angle, or a ray from the origin to A. You could even do it to, D, D, D. You could draw it to C, C. They chose A, A here. So A, they drew a ray from the origin, and our new shape, they drew a ray to A from the origin. And if you were to measure this angle, it would be 270 degrees, as they have posted here. So we're actually going to, let's see, we can draw, I'm going to freeze this. Let's use using the rays method. So I have here a triangle, and it has been rotated to the left. So I know it is a positive angle of rotation. It's going counterclockwise. And we can do G to G, we can do H to H, we can do F to F. Let's do F to F. So if I draw a ray from the origin, which is 0, 0, to F, and a ray from the origin to the new F, it's just a straight line. But what do I know regarding angles about a straight line? Well, I know a circle is 360 degrees. If I split that circle in half, using a line, I'm splitting 360 degrees in half. So 360 divided by 2 is 180. So this straight line, all straight lines, measure 180 degrees. So this shape actually started here and it rotated to the right. So it is a negative angle of rotation. And it rotated here. So 180 degrees of rotation clockwise, so negative 180 degrees. So, with that, I'm going to go ahead and put in my points just to prove that it's a 180 degree rotation. So if I start with here, I have F. Let's go here this and come back to it. So F, I have F, G, H. Okay, so F I know is -1, 2, 3, 4, 5, -2. So -5, -2. G is -1, -2. 1, 2. H here is I walk before I can fly. I go over 1. So that is -1, up 1. 1, up 1. Okay. So now if I rotate my image, it's a -180 degree rotation, which is going to be clockwise. So it's going clockwise. I know if I go back to my rule, F, without even looking at this, I'm just going to ignore that for now. My F, my rule for 180 degree rotation is both my X and Y coordinates are becoming the opposite, or becoming negative. and they stay in the same place. So this -5 and this -2, they become opposites. So that's just regular 5 and regular 2. Regular 5, regular 2. And if I look here, if I go to H, if I go over 5 and up 2, is that where my F is? Let's see, 1, 2, 3, 4, 5, 1, 2. That's F. I could do the rest of these and solve it, but I think my video is getting a little long, so I'm going to stop here. But that's pretty much it.